A supercritical fluid is a substance held at or above its critical pressure and temperature, which causes the liquid and gas states to become virtually indistinguishable from one another. Wait, what? Let's start by talking about states of matter. The three most common states of matter are solids, liquids, and gases. In a solid, molecules are tightly packed together with relatively little movement, and the substance retains its form when put in a container. In a liquid, the molecules are a bit more free to move around and fit the shape of their container. With gases, the molecules are much more free and fill both the shape and volume of their container. Substances can move between these states through processes known as phase changes. Solids can change to liquids through melting, such as an ice cube melting on a hot day. Liquids can change to gases through vaporization, like boiling water changing into steam. A substance at any state can change to any other state through similar processes, given the right conditions. Let's focus on switching between liquid and gaseous states. A liquid substance can become a gas through vaporization under certain conditions, when the temperature of the liquid is raised and the kinetic energy of the particles rises, causing the molecules to have enough energy to escape the liquid, or when the pressure of the system is lowered, causing less interactions between the liquid and gas particles and lowering the chance of liquid particles evaporating. Also, a gas can change to a liquid through condensation under the opposite conditions, low temperature or high pressure. These relationships are maintained through a large range of pressures and temperatures, but for each substance, there is a highest temperature at which a distinct liquid can form from a gas, known as the critical temperature. Take carbon dioxide, or CO2. When most people think of CO2, they think of a gas, which is its natural state at room temperature. However, CO2 can become a distinguishable liquid at any temperature below 31.1 degrees Celsius, or about 304 Kelvin. At this temperature, a pressure of 72.9 atmospheres or higher is necessary to form a liquid. This pressure is its critical pressure. The temperature and pressure values of 304 Kelvin and 72.9 atmospheres together are known as the critical point of CO2. Where did these numbers come from exactly? Well, at any temperature higher than 304 Kelvin, no amount of pressure can be applied to gaseous CO2 to form a liquid. What results from CO2 at a temperature higher than the critical temperature and a pressure higher than the critical pressure is a supercritical fluid. This substance fills the container it is in, much like a gas, but the molecules are extremely close together or dense, much like a liquid. This odd combination makes it indistinguishable as a liquid or a gas, meaning it can't properly be defined as either. Okay, this whole process seems kind of impractical. Why is this important? Like most liquids, supercritical fluids can dissolve a wide range of substances. Supercritical carbon dioxide, in particular, is widely used in the food industry in a process called supercritical fluid extraction. It is used to dissolve the caffeine in coffee without removing the smell or producing virtually any waste. And it's pretty cheap. So, the next time you drink decaf, remember that supercritical fluids are making that possible.